Alright, so you've got your beautiful Godot game that is going to stun the masses, and you want a high scoreboard for your users. This will be a quick and dirty walkthrough showing you how to accomplish that at a very basic level. So what do we need? First up, we'll need your Godot project. Each player will have their own copy, and these copies will not talk to each other in any way, shape, or form. Secondly, we'll need a server. The server is the portion that stores your high score and must be running 24/7 so anyone and everyone can access it at any time. The server can be a simple web server so long as it can have a database and execute PHP code. In this walkthrough, I'm expecting that you have access to a server and you can modify its database and create PHP pages for it. If you don't have a server already, you can set up a local one on your computer just for testing. To do this, just go to this page here, I'll have a link in the description, and download the package that matches your operating system. I will not be covering how to set up this local server on your machine. You're going to have to do some research on your own. So lastly, I do expect that you have at least a basic understanding of SQL, PHP, and GDScript syntax. If you don't know one or more of these languages, you need to at least be able to infer how things work by looking at their code, as I will not be going too in-depth into how each language works. The database used in this walkthrough is a Maria database, but everything should work the same on, for example, a MySQL database. If you don't know what a MySQL database is, pause the video and do a quick search on the duck. So how is this going to work? We basically need to make 3 different elements that all talk to each other. It isn't extremely difficult per se, but there are a lot of moving parts to keep track of. Our first part will be the database itself, where we need to make a table that can store our players' scores as well as their names. Our second part will be a PHP web page that passes messages back and forth between your Godot game and our database. Unfortunately, we can't have Godot talk directly to the database, so this mediator is required. Our third and last part will be making Godot talk to our PHP page so we can send and receive high score values. With that cleared away, let's start our database first. Go to your website's database page. If it is a server on your machine, it would likely be at localhost/phpMyAdmin. If your website is hosted elsewhere, you will probably have to go through your account page to access it. We are going to create a new database to store everything related to our high score system. In the case of this demo, I named mine HS_DB, but you can name yours whatever you wish. Next, we need to create a new table in our database to store all our scores. Our table needs to store 2 values, the name of the player and the score that the player got. Each value we need to store is known as a column. So, when creating our table, let's call it high scores, we will say to create it with 2 columns. Alright, so this page here lets us define our columns. For our first column, let's call it username, and make it a varchar. A varchar is effectively a short string that can have a variable number of characters between 1 and whatever maximum value we set. In this example, I set mine to 24, as that is the maximum number of characters I want to allow for a username. We will also need to make sure that we check this in our PHP script later. Since we don't want a single user to flood the high score table, let's make sure we can only have one of each username. With the index dropdown, go ahead and select Unique. Press Go on the pop-up that shows up, and we're good to go. For our second and last column, let's call it Score, and keep it as an int unless you specifically want decimals in your scores. In that case, you could set it to float. That's it for this table. We do need one more table to act as a simple layer of security, however. It will effectively hold permission slips that lets us know if a player has permission to add scores to our table. I will expand on this later, but for now create a new table named nonces and give it 2 columns. Our first column should be named IP address and set to be a varchar of size 255. We want to make this one unique so each person can only have 1 permission slip at a time. Our second column should be named nonce, and this should be of type char, with a size of 64. This will act as our security code for the permission slip, and it will always be 64 characters long. Once you have this table created, we are effectively done setting up our database. That is all there was to it. For our PHP side of things, we are going to create a dedicated PHP page just for handling requests. We need 3 features implemented for this to work. First, parse any incoming data from Godot. Second, send and receive requests from the database. And thirdly, form a response to send back to Godot. As we start designing these 3 systems, There are also 3 common types of cheating and hacking that we want to be aware of so that we can create our systems to be resistant to them. These 3 types of hacking are as follows. The first is SQL injection. To put it simply, it is the user making our database execute commands we don't want it to. If the user puts SQL commands inside their username, for example, we don't want the server to execute them when we store the username. Replay attacks are another one. This is where the user effectively copies the message sent to our server and manually sends it multiple times. This can allow them to make multiple score entries, among other things. This is where our permission slip feature will come in handy. Lastly is simple value hacking. We don't want them changing the value of their score manually before the message gets sent to the server. So in review, we'll need to program our PHP page to parse any data from Godot, making sure that the data wasn't tampered with and was only sent once. Then we need to make our PHP page talk to the database while checking for any SQL injection and weeding that out. Lastly, we have our page send a response back to Godot. Alright, enough of that. Let's get to some actual code. You'll need to create a PHP page on your website that will handle all of this. I called mine highscore.php and put it in the root directory. The first and simplest part of this page is sending data back to Godot. Basically anything that is printed on this page will be sent back to Godot. So in the above example, the words "Hello World" would be sent back to Godot as a message. Sending back some JSON is just a matter of formatting our echoed output in the form of a JSON string. So let's get started with this first. We can start by making a function that takes a dictionary and forms it into a nice JSON format. We then just echo it onto the page to actually send it back to our Godot game as a JSON structure. That is all that's required to print out our JSON response. However, let's add a way to report if we had an error. Let's make our JSON instead have 2 keys. The first will be error, with the error that occurred as a string, while the second will be response, which will contain our dictionary values. If you are new to PHP, there are 2 elements to the displayed code that may seem odd and require some explaining. The first is all of the periods. In PHP, when you need to concatenate 2 strings, you must do so with a period rather than a plus symbol. The second is that I was able to type the variable error directly into the string. This is a feature of PHP that will insert the value of the variable directly into the string without having to explicitly concatenate it. It's just some shorthand that makes combining strings a bit cleaner. So how do we actually receive data from Godot? Well, PHP has a special dictionary variable called _request. When we send data from Godot, it is sent as a number of key value pairs, similar to a dictionary. All this data will show up in this special PHP variable. But first, what kind of data are we going to need? Let's think of a label for each kind of data we want to handle. Well, first, we need to be able to specify a command, such as sending a score or asking for scores. Let's call this piece of data command. This can just be a string which holds the name of the command we want our server to do. We also need to be able to specify some dynamic data. So when sending a score, we need to be able to send the username and the score itself. But when retrieving high scores, we need to be able to specify how many scores to retrieve and where in the scoreboard we should start. Let's call this one data, and we can send it as a JSON string. We will also need to send some security data, but we'll handle that a little bit differently later on. So with this in mind, let's just add one more tweak to our print response function. Let's add one more key labeled command and print out whatever command we received from Godot. This will make it easier to know which response belongs to which command inside of Godot when we get our responses back. Alright, so that is all that is required to send a response back to Godot. Let's get started with processing incoming requests. All the code on this page will automatically execute when a message is sent, so we first need to check that the message has all the expected values. We need to make sure that Godot sends us some kind of command as well as some data to go along with it. So here you can see where we check the state of our command. First, we check that our request even contains a key called command. If it does, then we check to make sure it was given a value. If either of these situations are false, then we don't have a valid command and we can report the error back to Godot. This little line that says die simply tells the PHP to stop executing. This would prevent any further code on the page from being processed. The code for checking if we had our dynamic data sent over is pretty much identical, with the exception of throwing a different error name. Next up, we need to make our script connect to our database so we can execute any commands requested by Godot. We will need a few properties in order to connect. First, we need the location of our database. In some cases, such as when hosting on your own computer, this will be the actual web address of your site. In other cases, such as shared hosting, it will be a special address that you can find in your admin panel. Secondly, we need the name of our database. This will be the name we gave it before, or, again in some cases, such as shared hosting, this name may be assigned for you. Note that this is not the name of the table that we created, but rather the database that contains our two tables. We will also require the username and password to log into the database. If you are hosting your own site using the tool provided at the start, then the default username will be a root and the password will be an empty string. Now, remember how SQL injection was one of the problems we needed to look out for? This is the time that we must figure out how to handle it. If accessing your database directly, you would send your commands as text generated by PHP. For example, we may set a high score like this. Okay, so what happens if the variable username is set to something crazy kind of like this? This would add both the entries Bob with that crazy high score and the entry Haxers with their original score. We could try manually checking each username to prevent this, but this would be quite the undertaking. Luckily, PHP comes with a library named PDO. This library can take care of this for us. Instead of submitting SQL commands directly, we build a template command and let PDO plug in the values. PDO then makes sure that none of our plugged-in values would allow for SQL injection. Using the same example as before, our command would change to look something like this. We would then give PDO our username and score values and say to plug them into the username and score spots, respectively. That is why we will be using the PDO library, but first, we need to actually connect to our database. So here we create some variables to hold our database login details that we just discussed. Generally, it would be a good idea to place these details in a separate PHP file for security reasons, but in the case of this walkthrough, we will just include them here directly. Next up, we need to format everything in a way that PDO will understand when we initialize it. Some of this, such as the connection port, is just boilerplate that will generally remain the same for most connections, except in some unique situations. When we try to connect to our database, it is possible for something to fail. Here, we just catch any and all problems and report a generic database error to Godot. You could optionally report back some details about the error by including the variable e in your response. That is the connection portion of our code completed. At this point, your PHP script should be connected to your database and you can easily send requests to it. Now we can actually begin handling our Godot requests. What we will do is create a switch statement with a case for each valid command we wish to handle. If an invalid command is sent, then we will simply return a generic error back to Godot. So first things first, let's grab the JSON string sent from Godot and turn it into a dictionary. If there's an error in the JSON, then PHP's decode function will return null. With that out of the way, we can begin our switch statement. The first command we will implement is adding a new score to our table. We need to do two simple checks to make sure our JSON contained a score and username to submit before we try adding them to the database. Remember how our database limited our usernames to 24 characters? Let's make sure to add a check for that here in PHP before we send it over. Since we are using PDO, we can form our request template now. Here, we specify we want to add a new entry to our table, high score. Note that these are not single quotes, they are backwards quotes. The columns we want to define are username and score. The values we want to give these columns are our PDO placeholders. In the case that the username already exists in the table, we want to update the score rather than add a duplicate entry. This duplicate key portion knows to check the username and not the score for duplicates because we specified in our table that the username should be unique. We then update the score to the larger of our two values. The existing score or our new score. Now that our template is done, we can give it to PDO to get things ready to send. We then execute our command on the database while providing the actual username and score we wish to send over. Lastly, we send a simple response to Godot to let us know that there were no problems. So far, so good. Now, let's add a way to fetch our scores. When fetching scores, we should be able to, but not be required to, set an offset in the table to start fetching, as well as the number of scores we want to fetch. We can set some simple defaults here. As our scores will be sorted from best to worst, we will default to an offset of 0, which should be the highest score. If Godot specified an offset or number of scores to fetch, we then modify our values accordingly. Again, we must create our PDO template. We specify that we want to sort our results based on the column score. We also want the scores to go from highest to lowest. We can limit the number of results we fetch, as well as offset our starting point in the scoreboard. Notice the asterisk here. This is where we specify which columns we want to retrieve. If we place an asterisk, then it just means that we want to retrieve all the columns in the table. So for example, if you didn't actually care about the score but just wanted the username, you could just type out username here and it would only grab the username from the result. Now, unlike setting a new score, we actually need to specifically fetch the results after sending the request to our database. Here, we specify to fetch all the data that we requested. This will give us an array where each index is a result from the scoreboard. Each result will be a dictionary containing the table elements we specified in our request. We can pass this result directly back to Godot with our print response, but let's go ahead and add a key letting Godot know how many results we fetched. When we send this back to Godot, the data should look something like this. Alright, so we should now have enough code implemented that we can actually test out our page a little bit. Go ahead and open a browser and navigate to your highscore.php page. Uh-oh, looks like we have a PHP error. This is a good example of what an error shows up like on your page. If you were to make a request from Godot and have an error occurred on your PHP page, this would be returned in full back to Godot. So if we take a look, it looks like we're missing a symbol, and it's going to be on line 21. As it happens, we forgot to add a closing parenthesis in one of our if statements. We give it another go, and it looks like we have a different kind of error. This one isn't a syntax error, it's more of a logic error. The error occurs on line 7, and it appears to be that we're trying to access a key that doesn't exist in our request dictionary. This is happening because when we're missing our command, we're still trying to throw an error back that specifies the command that was requested. In this case, we'll just bypass our print response function and echo out our error directly. We give it one more try, and everything works as expected. We get an error stating that we didn't specify a command. So now let's try actually executing something, such as adding a score to our high scoreboard. Let's pretend that the user named Bob made a high score with a value of 1,000. It looks like things worked correctly. No error was returned, and we were given an empty response. Next up, let's try grabbing the score back from the high score table. And this is where we're going to come across a couple errors with PDO that we'll have to address. Note here that even though we don't want to specify anything, we still have to provide some kind of JSON data in our parameter. Alright, so it returned, we didn't get an error, but look at that, our size is 0. Shouldn't we have a score in there somewhere? This happens to be a problem with our placeholders when we're making our PDO template. In this case, PDO doesn't realize that our variables are integers, so it's inserting them into the template as strings. Now before, we specified what the placeholder should be replaced with directly in the execute command. This time around, we're going to manually set each placeholder ourselves and specify explicitly that they must be integers. There we go, that's the main piece we needed. And now we execute again, this time not specifying our placeholders because they're already bound. So refresh the page, and this time we actually get a result. We have our score index, but look at this, we also have some weird other numbers floating around in here. What's with that? It turns out that when we specify to grab all the data with PDO, we don't actually specify how we want it. So it has a dictionary version and an array version, and it basically just meshes them together and then gives us everything at once in both versions. We don't want that. We just want the dictionary version so that it's really easy to grab our data without having to worry about array indices. So PHP calls dictionaries associative arrays. So when we fetch our data, we want to say that we want it as an associative array. We refresh our page one more time and look at that. We have a proper score index with everything else in order. Great, so all our code is working, and as far as this walkthrough goes, is feature complete. However, before we jump into the Godot side of things, we still need to finish our security. We still have to handle replay attacks as well as value hacking, remember? We are going to combine both of these things into a single function check called verify nonce. But first, let me explain how each system will work. To reduce the potential of value hacking, it can be effective to put everything we are sending to the server into a hashing function and send our request along with the resulting hash. When the server gets its request, it hashes everything as well and compares this hash with the one sent by Godot. If any of our data was changed on the way, the two hashes won't match and we know something is amiss. When hashing, we want to use a secret key that only the server and client know, as this key should be used by both parties to create our hash. Now, we are also going to mix in our permission slip system so that Godot has to ask for permission every time it wants to send a request to the server. This permission slip is called a nonce. Godot must request a nonce from the server and provide it back to the server when it makes its request. The server checks the nonce and then destroys it before completing the request. It is like a single-use access key. However, the nonce just floats around in the open as we send it back and forth, so we need to do a little extra work to secure it. When Godot gets the nonce from the server, we have Godot generate a nonce of its own, which we will call cnonce. When Godot hashes its request to send back to the server, it includes the nonce and cnonce in its data, but then only sends the cnonce back to the server. This means that when the server talks to Godot, it only sends the nonce, and when Godot talks to the server, it only sends the cnonce. We make sure to never send both of them together, while at the same time making sure both Godot and the server know what they both are, so we can check our hash. That's all there is to the security. It may seem a little confusing, but hopefully it will make more sense as we walk through the code. There can be a lot more added to security, such as encryption, as well as not cutting some corners that we will be cutting when implementing this. But what this walkthrough goes over should be more than enough as an introduction and for general use. Okay, so first things first, let's add support for a command from Godot that will create a new nonce on the server and send it back to Godot. To generate the nonce, all that we're going to do is generate 32 random bytes, throw it into a SHA-256 hash generator, and then store the hash on the server. Now ideally, each nonce would be guaranteed to be unique and with an expiration date. Now we aren't going to go that far in this example, as what we're doing here should be fine for casual use. However, if you ever plan on expanding to a very large audience, it might be worth considering down the road. So here we create the template for PDO that will create the nonce and store the user's IP address on the server. If the user tries requesting two nonces, it merely overwrites the old one with the new one. Finally, we send the nonce back to Godot. So next, let's create our nonce verification function. Now when we send the cnonce and hash value from Godot, we're not going to send it in the same way that we sent our regular data. Instead, we're going to send it in the headers. All that means for us is that instead of checking the _request global variable, we're now going to check the _server global variable. Next up, we check our server's database to see if there's a nonce associated with the user's IP address. Once we have the nonce in memory, we can delete it from the database so it can't be used again. So our last check here is to check the hash value to make sure that no data was changed when it came from Godot. As stated earlier, when creating the hash, we included the nonce, we also included the cnonce, as well as the request data, which is what this file get contents portion is. We also need to make sure that we include the secret key that we use to hash everything with. To finish off the security portion, we need to make sure that we verify the nonce when we get scores and set scores. Alright, so one last thing before we proceed to our Godot implementation. When you host your game online on a server different than the one that your database resides on, your browser will automatically do what is known as a pre-flight check before sending any requests. This pre-flight check is effectively your browser asking your server for permission to make sure it's allowed to send data across from one server to another. We need to add a little bit of code on our server to make sure that it gives permission. If we don't do this, then our game will only be playable if hosted on the same server that hosts the database. Most of this is done just by setting some headers. So, we first set which places the requests are allowed to be sent from, which in our case will be everybody. We also want to make sure that the connection stays open for at least 60 seconds. When a pre-flight check request is made, it will come as the request method options. When this happens, we have to specify what kind of methods of requests we allow, which will be options, as was just made, and post requests, which is what we will be using with Godot. We also need to make sure to specify what kind of headers we allow in our requests. Lastly, when it comes to actually sending requests that will modify the database, we only want to allow post requests. Earlier on, when we were making requests by just adding some text into the address bar, that's known as sending a GET request. We want to prevent others from doing that same thing, so we are going to limit the kinds of requests that we support. We are finally done with PHP. This was probably the toughest part of the implementation. Now we get to move to Godot and start interfacing with our server. For our demo Godot project, we will keep it relatively simple and mostly focus on the networking aspect. We will only create one scene with the root handling all the networking features. The children of our root node will consist of 2 buttons to allow us to send a randomized high score and name pair and receive the top 10 scores from the database. All requests and responses will just be printed out into the debugging console. As for the design of our networking node, we are only going to allow one request at a time, and our node should be able to handle automatically requesting nonces before sending our request. What we will do is create a queue that contains all the requests we wish to make. The requests will be formatted as a dictionary that contains our command as a string and our data as another dictionary. When we are approved to send our request to the server, we will send the command and convert our data portion into JSON. As our game runs, our root node will pop requests off of our queue and handle sending the data one request at a time. We can simply have our buttons queue requests as needed. Alright, so let's get started. Go ahead and create a scene with a control node as the root. We can create 2 buttons as children, one named Add Score and one named Get Scores, and center them inside of our control. Our first script will be our networking node script. Let's just outline our basic functions first. These are all the functions we will need. We'll need our ready function to initialize our networking node and attach our buttons, our processing function to check when requests should be sent, our HTTP request completed, which will handle catching all responses from the server. We will need a request nonce function, which will handle sending a request for a nonce. And then we will need a send request function, which will handle sending a request for any other command in our system. We also need a submit score function, which will be executed when we press our submit score button. This will generate a random name and score and queue it to our request queue. And lastly, we will need our get scores function, which will be executed when we press our get scores button. This will queue a request to fetch the top 10 scores in the scoreboard. Those are all the functions we're going to need, but we're also going to need some member variables. First up is our HTTP request, which will contain an HTTP request node. This node is responsible for actually submitting and receiving raw data from the server. We will have a constant named server URL, which should just be the full path to the PHP page we created earlier. We will also make a constant named server headers, which will contain some basic headers that are required for every request that we make to the server. We will have one more constant named secret key, which must contain the exact same key that we used in our PHP code to hash out our data. This was the second argument in the function verify_nonce. We'll need the variable nonce, which will contain the last unused nonce sent to us by the server. We will need request queue, which will contain all the requests we want to send to the server in the form of dictionaries. And lastly, we'll have the Boolean variable isRequesting, which will specify whether or not we are waiting for the server to respond. Alright, so our first function is our simplest, ready. We will add a call to randomize so our randomly generated scores are different each time. We need to attach our HTTP request as a child so that it can begin processing our requests. We also need to attach its request completed signal to our HTTP request completed function so we can grab the responses. Let's also attach our buttons to our score commands so that they get executed when we press them. Next up is our process function. We only want to make new requests if we aren't already requesting, and if we have requests waiting in our queue. If we are good to make a request, then we must decide if we need to request a nonce first or not, and call the appropriate function. So to request a nonce, we need to actually start worrying about how our data is formatted. When data is sent to the server, we need to be careful what characters we use. There are a large number of characters that have special meanings, and we don't want to send them directly. What we need to do is swap them out with placeholders. PHP will know to automatically convert them back for us, so we only need to worry about this on Godot's side. Godot's HTTP client object has a nice convenient function that can convert a dictionary into a proper string with all these symbols swapped out for us already, so we will use that to convert our request. Now, in the case of requesting a nonce, our JSON is empty, so this isn't strictly needed. However, we will still use this method here to be consistent with our sendRequest function later on. To send a request to the server, all the data goes into one string, where we simply assign our keys to a value and separate each key with an AND symbol. So, our request without placeholders should look something like this. We don't need any hashing or special characters when requesting a nonce, so we are good to send our request. Now, for this demo, I have SSL set to false because I am hosting locally. This needs to reflect your server, however. If your website starts with HTTPS, then this should be set to true. If your website only has HTTP, then it should be set to false. Generally, you always want to be able to set this to true so that data is sent securely to the server. Lastly, for this function, let's check if we had any connection problems. If not, let's print out that we are asking for a nonce. We will get to receiving data back from the server shortly, but let's go ahead and tackle sending a regular request first. So when sending a regular request, we actually have to handle hashing as well as generating our cnonce this time. To start, however, it is very similar to requesting our nonce. We grab our command and convert our data with an HTTP client as before. We create our request string the same way as well. So, to generate our cnonce, we can make it anything, but we will opt to use the same method as what we used in our PHP to generate our original nonce. This was just 32 random bytes thrown into a SHA-256 hashing algorithm. To generate our actual security hash, we are just going to prepend our nonces and append our secret key to our request string. Now this must match exactly to the order we used in PHP, otherwise the hashes will generate differently and the server will deny our request. That's it! We have our cnonce and we have our security hash. Now let's set the nonce to null so our system knows we need a new nonce before our next request. Now, in PHP, we programmed our script to expect our hash and cnonce in the headers instead of in the regular post data. Let's just grab our default headers and make a copy with our extra info before sending the request. That's all the extra work done. Now we can send our request and check for errors just like before. We will go ahead and print out our whole request so we can see what is going on. Our last bit of networking code is handling the response from the server. Let's pop over to HTTP request completed. First up, we know if this function is executed, then we are done waiting for the server, so let's mark our system good for a new request. First, we must check if Godot had any errors with the connection, such as failure to connect or denied access. For the demo, we will just print out the error, but you may wish to implement a fallback if this happens in your actual game. If we don't have any issues, we can grab the response as a byte array. We want to convert this into a string, so we have our JSON structure. Then we convert the JSON into a dictionary. Here, we check if we had any custom errors reported by our code. These are the errors that we manually specified to be returned by our server. In the case of this demo, we'll just print them out to the console. So first off, we want to check if our command was a nonce request. If so, we need to store the nonce and call it good. Our system will then automatically make the follow-up request thanks to our process function. If not a nonce request, then this is where you can handle all your other request types. In our case, let's just print out the response body so we can see the data we fetched. Let's just tackle our button functions, and then we're done. For get scores, it is pretty simple. We know the command is get scores, and we just want to grab the top 10 scores in the table. Generate our dictionary with these values and push it to our request queue. For our submit score, we can generate a random name and score to make a dummy scores easier to tell apart. You can skip this and just print a default value if you wish, however. Again, we form the dictionary and queue it to our requests. At this point, you should have a working demo. Let's run it and see what happens. Looks like we got an error, and this is a mistake on my part. I accidentally specified that we should look for the key result instead of response in the JSON that came from the server. Let's fix that up and give it another go. This time we have our application request a nonce, but it never actually follows up with the request. Again, this was a typo on my part. Once we get the response from the server, we should be letting the system know that the request is finished, not that it is still going on. Alright, let's try this one more time. And it looks like things are working. We have one entry in our database, which was that test entry that we added when we were still designing the system. Let's add several more scores into the system and make sure that it updates correctly. We fetch our scores, and this time we have 5 instead of 1. Looks like things are working properly. Well, that's the end of this walkthrough. Hopefully you found it useful. If you are watching this on BitChute or Odyssey, then feel free to post any questions you may have in the comments, and I'll attempt to answer them. I will also have a few useful references down in the description, so feel free to check those out. With that, have a lovely day and good luck with your projects.